that the scientist Dalton, in his atomic theory, stated that atom is the ultimate particle and it cannot be split up into any more further particles. So in his atomic theory, he said that matter consists of many indivisible atoms. But later, many scientists, through their experimental observations, concluded that atoms also contain of many subatomic particles, which are electrons, protons, and neutrons. So in this course, we'll be discussing all those experiments in details to know that what is the exact structure of an atom. Now, many attempts were made by different scientists. The first attempt was made by the scientist J.J. Thomson. After that, Rutherford also carried out an experiment which led to the discovery of protons or the nucleus. And then we'll also talk about Bohr's model. So let's start with the cathode ray tube experiment carried out by J.J. Thomson in 1897 that led to the discovery of electrons. So before J.J. Thomson carried out this experiment, it was considered that atoms were indivisible in nature according to what Dalton said, and it was almost considered to be true. So what J.J. Thomson did was, he just did an experiment in a glass tube with vacuum in it, and two metal pieces were placed inside it. He connected the two metal pieces with the power source and he switched it on. Now, as soon as he applied this power, he observed that a ray shot from the metal across the tube and the ray hit the other side of the tube and created a glowing spot. Now, as he proceeded further, he did not know that what was actually these ray made up of and what is the nature of the ray that is being produced from the metal. Therefore, in order to now check the nature of the ray produced, he brought charged metal plates near the tube. Now, this side of the metal plate is positively charged and the other side is negatively charged. Now, as soon as these metal plates were introduced, what happened is the cathode ray, instead of moving in a straight line, now shifted towards the A point. That is, it started bending towards the positive side. Now, further to confirm his experiment, he also introduced a magnet instead of charged metal plates and tried to know if there was still a deflection in the cathode ray. Because if anything has an electrical charge and it's moving, the magnet will push it in a particular direction. So as soon as he inserted the magnet near the cathode tube, again he observed a bending of the cathode ray. So with the help of this experiment, he concluded that the cathode ray must be made up of something negative. Why negative? Because only an opposite charge can attract each other. So since this cathode ray was attracted towards the positive metal plates, therefore the cathode ray must be negative in nature. And therefore he named these negatively charged particles as electrons. Further, Thomson also stated that the amount of deviation, that is, the amount of bending of the particles from their path in the presence of electrical or magnetic field depends upon the magnitude of negative charge on the particle. That is, more is the negative charge, more will be the bending, or more will be the deviation. Also, he said that the deviation of the particles would be further increased if the mass of the particle is less. So lighter the particle, greater will be the deviation. And lastly, the deviation of the particles would also increase if the strength of the electrical or magnetic field is increased. So with the discovery of electrons, he proposed a model of an atom which is known as J.J. Thomson model of an atom, or commonly also known as the plum pudding model or the watermelon model. Now, why this model is known as the plum pudding or the watermelon model is because, like in a watermelon, the seeds are embedded in the red part of the watermelon. J.J. Thomson said that an atom was electrically neutral, that we already know, and it also contains the negatively charged particles, that is the electrons, which he discovered. So he said that the electrons are embedded in an atom as negative charges, and all the other space that is present inside the atom is the positive charge that is spread out evenly in the atom. Therefore, on the whole, atoms are neutral and the positive charge is spread out evenly throughout the atom, and electrons are embedded in it. Now, later on, many other experiments were carried out by different scientists, and Rutherford said that although the atom contains negatively charged particles, but the structure of atom is not as proposed by J.J. Thomson. So the next experiment that led to the discovery of the nucleus was the Rutherford's nuclear model of an atom. So in the next lecture, we'll see that what kind of experiment was carried out by Rutherford and how did it lead to the discovery of the positively charged nucleus. I hope the lecture was clear to you. In case of any queries, do comment in the comment section, and please like and share the video. Thank you so much.